topic. Okay. So let's proceed with another example. We have discussed with what is periodic function, what is even and odd, and you know the importance of finding the types of function, is it even or odd or neither, in order to determine what type of expression that you want to obtain in terms of the Fourier series. Okay, so we have done with finding the value of L, identifying the value of T, the period, and then from that identifying the type of function from the graph, from the definition, is it even or odd or neither, in order to determine on what type of formula that you have to choose, okay, for you to construct the Fourier series. Okay, so now let's take a look at another example. Okay, still the same topic. All right, so from here we have the function and the Fourier series is also given. You just need to show. All right. So this kind of question, what you have to do first is what? You need to construct the value of L, the value of T, identifying the type of function there. Okay, so what is L here? What is the value of L for this example? Anyone? Yes, it is pi over 2, right? Because the range given here is in terms of negative L to L. So this is your L, right? So L is pi over 2. And you know that L equals to T over 2. Okay, so from here you know that T equals to pi as given here. T equals to pi. Okay, so for the case where T is not given, then you can find the value of T by using L value. Alright, so there are cases where T value is not given, so you can find the value of T from the value of L, where L equals to T over 2. Okay, so now you have your L, so this is your L, you have your L, you have your T, and you want to construct this Fourier series, you need to understand, you need to identify the types of function here. What is the type of function here? Is it even or odd or cos? As you can see, you know that this is A naught, this is AN, and BN is 0. Okay, because the series is given. But how can we prove that this function is what? When Bn equals to 0, which formula? When Bn equals to 0, what is the function? What is the type of function there? Even. Okay. So when Bn is 0, you know that the function is even. So in terms of graphically, you need to illustrate the modulus of sine there. Okay. So you know that this is the graph of sine, right? This is the graph of sine. Okay. So we just want our limit to be minus pi over 2 to pi over 2. So this is pi. So this is pi over 2. This is negative pi over 2. Okay. So in terms of modulus, all the negative values should be positive. So from the range here, it only involves here to here, right? So as you can see, it is symmetric about y-axis. So symmetric about y-axis. Now you know that your function is even. When your function is even, you consider the second formula where you have to find A naught and AN only, where Bn is 0. Is that clear? Okay, so before you proceed with finding the Fourier series, what you have to do is to find your L and then identify your T and then type subtraction. And then you can decide which formula that you want to use. Alright? Okay, so this fx is given. Of course, you have to use the second formula there. Okay? Is that clear? Siapa tu? Please mute. Alright. Is that clear? Anyone has question for this part? Okay, so now you know that you have to use this. You have to use the Fourier series of even where you just need to find a naught and a n only, where a naught is given by this, a n is given by this. Then just substitute. Okay, try to show the given Fourier series is obtained after using this function of sine x. Can you do it? Let's try to do it by your own first. After this, we discuss. I'll give you around 15 minutes. Can you? Anyone has question? All right. So of course, you know that we are going to use the second formula. Okay. Okay. We are going to use the second formula where you have to find a naught and a n. Right. So as for this one, a naught is given by 2 over L, 0 to L fx dx. So 2 over L. L is pi over 2. So you have 4 over pi. Okay. 2 over L. L is pi over 2. Then you have 4 over pi there. So integrate from 0 to L. L is pi over 2. Fx is sine x dx. Okay. Sine x integrate. You got negative cos x. Substitute the limit and then you got 4 over pi. So everyone got 4 over pi here for a naught. I think there should be no problem with a naught, right?
Yes, sir.
Okay. So now let's proceed with an. So this an, as you can see, Fourier series itself is an expansion of cosine and sine. Of course, the usage of trigonometric function will use the identity in order to simplify. So don't worry, all the identities will be given in a formula. So you have to know what identity that you can use. Right, so now let's proceed with an. So finding an should be 2 over L integrate from 0 to L fx cos n pi over Lx. Okay, so now 2 over L same 4 over pi. Okay, so fx is sine x cos n pi over L cos n pi over 2 will give you cos 2nx, right? Dx. Right, so n pi L n pi x over L, so n pi over 2x will give you 2nx. Okay, so now from this, we can put 2 here in order to match with this identity. So instead of 4 here, now this sin x cos 2nx is 2 sin x cos 2nx, where this 4 is factorized to 2 times 2. Okay, is that clear or not? So now you have, instead of sin x cos 2nx, now it becomes 2 sin x cos 2nx. So this is 2 sin x cos y, 2 sin x cos y, where it can be decomposed to this identity of sin x plus y, sin x minus y. Okay, so this is your x, this is your y. So sin x plus y plus sin x minus y. So this is by identity. right? So now these 2 sin x cos 2nx now becomes sin x plus 2nx plus sin x minus 2nx. And then you just put 2 outside. So why we have to factorize or simplify by using identity? To ease the process of integration, right? Of course, you can use substitution and so on if you have another option. So what I'm showing here is just to ease the process of integration. So we need to simplify the expression by using identity. Okay, now from this, of course, it's going to be easy for you to integrate. Integrate sign, you got negative cos x plus 2nx, differentiate inside the bracket, and then you got 1 plus 2n. Okay, integrate sign, you got negative cos, again x minus 2nx, and then differentiate inside the bracket, you got 1 minus 2n. And don't forget to put the limit from 0 to pi over 2. Okay, up to this point, is that clear, everyone? Okay, so now, once you have done with the integration, substitute the limit. Okay, so now 0 to pi over 2, substitute to x, right? X, 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 and x. So here becomes pi over 2, pi over 2, pi over 2, pi over 2 minus with 0 and 0 because 0 plus 0, 0 minus 0. That's why you got 0. So this one, this cos pi over 2 plus 2 and pi over 2 now can be reduced to another identity. Cos A plus B equals to cos A cos B minus sin A sin B, where initially it is cos pi over 2 plus n pi, cos pi over 2 minus n pi. Now it becomes cos pi over 2 cos n pi minus sin pi over 2 sin n pi. Right? And then this one, cos pi over 2 cos n pi plus sin pi over 2 sin n pi. Okay, so the sign here refer to the sign inside the bracket. And initially, it is all 0. So this one, 0, cos pi over 2, 0, sin n pi 0, cos pi over 2, 0, sin n pi 0. So what's left? So what's left is this one. So what's left is this one. Okay, the rest are all zeros now. So now what you have to do is to simplify. Okay, so make sure that the denominator are equal. So you just multiply here, 1 here with 1 minus 2n, and 1 here with 1 plus 2n to make sure that denominator are equal. Okay, and then simplify here 2 over pi, here 2 over pi, and then this one becomes 2, and then this one expand, become 1 minus 4n squared. So this is an. An is 2 times 2, 4 pi 1 over minus 4n squared. Okay, once you got your an, just substitute again. This is your a naught over 2, so become 2 over pi. Okay. Now this is a naught, and then plus with summation n equals to 1 to infinity of an. So this is your an cos n pi over lx. So cos n pi over L to nx. And then this one, 4 over pi here is a constant, so put outside. So in order, if you just got the answer up to this, then it is well done. It is correct already. But we have to show that it should be equal to the expression given, where it is 2 over pi minus 4 over pi summation of 1 over 4n squared minus 1 cos 2nx. So now, instead of this, you just rearrange, then rearrange this, then this sign also change. Then it is over. Is that clear? For what? For 2 sine x cos y equals to sine x plus y sine x minus y. Which part? This one? This one? Sine pi over 2 is not 0. Sine n pi is 0, right? This one. This is 0. Sine n pi is 0. Then everything here is 0. This one cos pi over 2 is 0. Then everything is 0. Okay. Alright, so for Firdaus, here we have sine x cos 2nx, right? Initially, we have sine x cos 2nx, but we have the identity of 2 sine x cos y equals to sine x plus y plus sine x minus y. So now we have sine x cos 2nx. Okay, so if we put 2 here, then outside from 4 now becomes 2. So 2 times 2 is 4. So we put 2 here, 2 here, 2 here. So 2 sine x cos 2nx now becomes, this is your x, this is your y, become sine x plus 2nx plus sine x minus 2nx. So now that's why we have this. Okay, clear? So we just integrate from here to here. Why it is easy? Because it involves only addition and subtraction instead of the substitution and multiplication then. Okay, is that clear? All right, take a look at the whole process so that you can understand better. If you have problem, you can ask. I hope you can see it all. Okay, try to understand this first. If you have problem, you can ask, right? Okay, so I hope everyone can try to do it again by your own and compare with the answer given here. Okay, so now let's proceed with another example. So as for today, we're just going to discuss. Okay, so example 7. I'm going to leave you with this example after this so that you can discuss. So first, what we have here is the value of L, of course, right? So remember, your periodic function is always given from the range of minus L to L. So even though it is a piecewise function, so this should start with your minus L and should end with L. Okay, so this is your negative L, this is your L. So your L equals to pi, and you know that L is T over 2, then T equals to pi. So exactly T equals to pi from here. Okay, so this is the most important step before you can start with finding the Fourier series. Now, as you can see here, from negative pi to 0, the graph is x. Okay, so initially fx equals to x is here, right? But now we have the limit from negative pi to 0, the graph is x. So you just stop until 0 here. And from 0 to pi, the graph is 0. So as you can see, if your symmetrical line is y-axis, it is not symmetric. If your symmetrical line is about the origin, it also not symmetric. So it is neither even nor odd. That's why fx function fx equals to x and 0 here from negative pi to pi is neither even nor odd. So when you have neither function, neither even or odd function, means you have to use formula 1, right? Where from the Fourier series here, you have to consider all A0 and AN here. Okay, this one. All right, so actually, this Fourier series is given by this. Okay, this is the full version of Fourier series. So if it is even, then Bn 0, then that's why we have here. Then if fx is odd, then an is 0. Then that's why we have here. So initially it comes from this. So from neither, when your function is neither even or odd, then you have to consider all a0, an, and bn here has value. So you need to find this a0, an, and bn one by one. Okay. So according to the first formula here, you have to find your a0, an, and bn for this example. So basically, you know that your a0 is from minus L to L. 1 over L minus L to L fx. And minus LA from minus pi to pi. And you know that it is divided to two functions from minus pi to pi here. So minus pi to pi means minus pi to 0 first for x and 0 to pi for 0. But eventually the function here is 0. So we just focus on the first part. Okay, that's why it is also applicable for an and bn. Okay, but if you have a function here, then you have to use the correct way to apply the limit from minus pi to pi there, because this is a piecewise function, right? So now try it by your own. Find a0, an, and bn. So the answer here is given. And then once you got your a0, an, and bn, just substitute to the Fourier series. Can you do this? Right, so the steps are there. The steps are similar, even though it is even, odd, or neither, but the process of integration will differ for each cases, right? So you can try to do it by your own. And if you have problem, you can ask. Okay, so I'm going to leave you here. So please try it by your own. Okay. So any question for today? So from 1 to 10, where are you?